question number 7, the final one. It's about integrating between two lines and finding the area between a curve and a straight line. First job, sketch the curves. In the exam, you might be given the curves, but if you're asked to sketch the curves, well, first thing that I would say to myself is x squared, y equals x squared, is a curve that's symmetric about the y-axis. That's what y equals x squared looks like. And the fact that it's 3 there means that if x is 0, y would be 3. So it cuts the y-axis at 3. So I know that the curve is going to be a symmetric curve about the y-axis, not very symmetric there, and it's going to cut at 3. I know that this point here is 3. And now another curve is coming on, a straight line is coming along, which is this, y equals 7. So I know it cuts at 7, which will be around about here somewhere, and then it's a negative gradient, negative 3x. So it's going to be a straight line that's going to come down a bit like this. So if I extend this curve up a bit, I'm actually after this area between the straight line and the curve. So what I'm after doing is integrating the straight line between these 2 points here and here. So I'm finding the area under the straight line between those 2 points. And then I'm finding the area under the curve between those 2 straight points, which is this area here, and subtracting that from the area under the line. So what I need to know before I can go ahead and do this integral is what these points are. I need to know these points. So I'm after these points. Now in the exam, if you don't know what these points are, you can't go ahead and in fact complete the question. So it's quite likely I'll say to you in the exam, these are the points, but then say, can you show where those points come from? And this is how you would do it. What's true about these 2 points is that these 2 points here and here are points which lie on the line and the curve. So at those points, y equals, the curve, the equation for this curve equals the straight line. So I can say that x squared plus 3 equals 7 minus 3x at the intercepts. So I've got a little equation to solve that will tell me what x is. All I've got to do is solve that equation. So I'm going to get everything over the left-hand side because it's going to be a quadratic because of the x squared. So taking the 7 and the minus 3 over to the left, I get x squared plus 3 minus 7 plus 3x equals 0. Plus 3 minus 7 is minus 4. So I've got x squared plus 3x minus 4 equals 0. And I've got a quadratic equation to solve. We've got the quadratic formula. If you look at the formula sheet, then you'll see on there, I think under the general formulae, oh, it's not on there, so yeah, you'll need to remember the quadratic formula if you need it. However, in this case, because the limits are likely to be whole numbers, it's quite likely this thing will factorize. And if we look at this, we're looking for 2 numbers that multiply together to give minus 4 and add together to give 3, which are 4 and minus 1, because 4 times minus 1 gives minus 4, and 4 minus 1 gives 3. So I can rewrite this as x plus 4 times x minus 1 equals 0. Do you remember this idea of factorizing? If I multiply out these brackets, I'd get back to this. You can try it and see that that works. So we've factorized it, and now we can write down what x is, because the right hand side is 0. Either the first bracket is 0, x plus 4 is 0, in which case x equals minus 4, or the second bracket 0, in which case x equals 1. So we've got our values of x, our limits. X equals minus 4 or 1. So now going back to the problem, we now know that x equals minus 4 or 1. So we know these limits are minus 4 or 1. And so we know these values. So I'm going to integrate the line 7 minus 3x between minus 4 and 1, and then integrate the curve between minus 4 and 1 and subtract the curve away from the line. So I'm going to end up with the integral, so the area equals the integral between 1 and minus 4 of the straight line, which was 7 minus 3x, with respect to x, minus the integral between 1 and minus 4 of the curve, which is x squared plus 3. So I just work out those two integrals and then subtract one from the other, one answer from the other, and I've got the area underneath the curve. See if you can go ahead and do those two integrals. We could actually combine the two into one. We can actually say that's the integral between minus 4 and 1 of 7 minus 3x minus x squared plus 3 with respect to x. And so that will give us 7 minus 3x minus x squared minus 3, so that's 4 minus 3x minus x squared with respect to x. So I could do that. I could combine the two. Because they're within the same limits, I can actually combine them and do the integral that way. Be careful of this. Minus x squared is minus x squared, but minus and 3 is also minus 3. So minus 3 plus 7 gives us 4 here.
You realise you just ended up with the same quadratic equation.
Yeah, which is the same as the quadratic we had at the top. That's true. Yeah. So integrate it, we get this. Now we put the limits in. So using curly brackets, we end up with that. I'd suggest you tidy it up. Don't put that all into the calculator in one hit, because errors come in at that point. I'd always try and tidy it up before I put it into the calculator. So I'll probably do something like that, and then I can put that into the calculator, and out will come the answer, which is, so the answer turns out to be 20.87.